Alright, here's section 8.2. One of the weird things about 8.2 is it's mostly about mechanically reading computer readouts. So it's a little bit different. It's not very conceptual. It's just about what is this, what is this, what is this. First thing to remember is our hypotheses. Our hypotheses are that M1 or MA is equal to MB, which is equal to MC. That our null hypothesis is that the mean from each of these groups is the same. Our alternative hypothesis is at least one M is different. And here you can see that as long as these things meet the requirements for ANOVA, we're going to be able to reject the null hypothesis. Reading whether or not to reject is very easy off these things. We can just look at the p-value. The p-value here is well under 5%. So for most reasonable levels of hypothesis, we're going to be able to reject them. One thing that we do have to make sure is that it's okay to do ANOVA in the first place. In order to do ANOVA, a couple things that we assume. We assume, first of all, that each of these subsamples comes from a basically normally distributed population. And we also assume that the standard deviation for each of these subsamples is basically the same. And here you can see these standard deviations are pretty close, and we're just going to say, okay, we're going to assume that that normality thing is met. So we can do a hypothesis test for these hypotheses right away. We can see that we would reject the null hypothesis. So consequently, we can prove that at least one of the population means is different from the others.